Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 16, 2025, just yesterday. The standout claim is a scalable recipe that constructs thousands of simulated tool environments and then trains agents in 2 phases, which yields state-of-the-art function, calling among open models under 1 trillion parameters. The paper is titled, Towards General Agentic Intelligence via Environment Scaling, and as we will see later, the implications for model training are quite significant. In short, the work ties broader, verifiable agent experience to stronger tool use, delivering compact models that rival much larger systems. On X, reactions highlight that Tongyang Lab released several agent papers, with a thread walking through benchmark gains and a follow-up noting AgentScaler trains function, calling in fully simulated environments toward general agentic intelligence. Engagement looks solid, with roughly 400 likes. Alright. The previous item sketched the big claim and community reaction. Figure 1 shows how the system constructs environments and then generates verifiable tasks, which matters because consistent state transitions let models learn reliable tool use. The left panels start from tool documents, form a tool graph, and detect domains. The center panels materialize each environment with grounding functions, a database like state structure, and a sample tool sequence. The right panels define tasks with user intent, an initial environment state, and a gold environment state for checking outcomes. So the previous figure outlined how tasks and states were assembled. Figure 2 shows the live interaction loop where a simulated user chats with a task agent, which triggers function calls that read and write the environment. The panel on the right tracks tool executions and database changes, so interaction traces can be compared with a gold action sequence, and the final environment state can be checked against a gold environment state. This setup provides verifiable supervision because every turn links a call to a measurable state update. Alright, the previous figure illustrated the verifiable interaction loop. Figure 3 presents scores on ACEBench English, split into normal, agent, and overall, and it compares the base QN3, thinking 30, BA3B, with Stage 1 and Stage 2 models. The bars show that Stage 1 already boosts agent tasks substantially over the base, and Stage 2 lifts them further, which raises the overall score as well. Normal tasks stay roughly saturated, so the gains largely come from stronger tool use. So the previous figure highlighted English results. Table 2 reports ACEBench Chinese, comparing QN3 baselines to AgentScaler models across normal, special, agent, and overall. The 4 billion model jumps from 6.7 to 38.4 on agent and lifts overall by 21.7 points, which shows strong tool use gains. The 8 billion variant improves agent from 35.0 to 58.4, while overall rises modestly. The 30 billion A3B climbs to 64.1 on agent and reaches 81.5 overall, so benefits persist at larger scale. Well, the previous table focused on Chinese results. Table 1 presents main results across TAOBench, TAO2Bench, and ACEBench English, which compares closed source and open source models on retail, airline, telecom, and overall categories. The key takeaway is that AgentScaler 30BA3B ranks near the top among open models, scoring 70.4 on TAOBench Retail and 60 on TAO2Bench Airline, and 60 on ACEBench Agent. The 4B and 8B variants also close large gaps, so environment scaling delivers competitive tool use at smaller sizes. Alright, the previous table compared broad benchmarks across domains. Figure 5 shows task accuracy as the number of tool calls increases, with separate trends for retail and airline domains. Accuracy peaks around 6 to 8 calls, then declines, which indicates that longer call chains introduce more failure points and compound small errors. The airline dotted trend drops faster than the retail dashed trend, so domain complexity likely magnifies this effect. Bubble sizes encode sample size, and larger bubbles cluster near mid-lengths where accuracy remains relatively high. Alright, the previous figure analyzed accuracy versus tool call length. Figure 4 shows Pass-K results on TAO2Bench across retail, airline, telecom, and a weighted overall panel, comparing AgentScaler to QN3 thinking 30BA3B. The solid purple line sits above the dashed baseline in 3 panels, so broader environment training raised top K success. The airline panel crosses at K equals 2 and favors the baseline at larger K, which suggests variability by domain. The weighted overall curve still leads consistently. Wrapping up, 2 takeaways stand out. Scaling fully simulated, verifiable environments unlocks broad, reliable function calling, And a two-phase curriculum first teaches general tool use, then sharpens domain skills, which lifts compact models to near top tier. The broader implication is efficient agent training that reduces parameter bloat. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.